Welcome to Chapter 4. This is our chapter that starts our trigonometry section of the class. And we're going to be talking about radians and degree measure in the first section. Now we're going to split up the first section in a couple different parts. So we'll be kind of going through and getting our bearings as it comes to trigonometry. So we're going to be talking about an angle. Once again, an angle has two sides and a vertex. Our sides are the initial side and the terminal side. The initial side is where we say the angle starts. The terminal side is where it stops. Now we're going to commonly see our angles in this standard position. And in that standard position, you can see your initial side is going to be on that x-axis. And the vertex is going to be at the origin. And your terminal side is going to go from the initial side to the terminal side. So it's going to start on the x-axis and then go to the terminal side. You'll be seeing different types of notation for angles. We usually label them with Greek letters: alpha, beta, gamma, theta. And those are just Greek letters that you'll commonly see to label angles with. Now we can have positive and negative angles. And when we have what are called coterminal angles, those are angles that have the same initial and terminal sides. So when we talk about an angle that has a positive angle measure, we're saying it's going counterclockwise. So counterclockwise is positive, and clockwise is going to be our negative. Now, here's an example of some coterminal angles. They have the same initial and terminal sides. Now, alpha is our positive angle. So it's going counterclockwise. And beta is our negative angle, and it's going clockwise. And you can see they have the same initial side on the x-axis and the same terminal side. Same thing with the next example. Now we have alpha going in that positive direction. And beta is actually going also in a positive direction, and it still ends in the same spot. We'll be talking about an angle like that that goes past the circle more than once. When we talk about the measure of an angle, it's determined by the amount of rotation from the initial to the terminal side. Keep in mind, when we're talking about angles, we have a circle. And a circle is 360 degrees. That's one rotation around the circle. Now, we're also going to be talking about a new measurement called a radian. And a radian is the measure of the central angle, theta, that intercepts the arc S equal in length to the radius of that circle. So a radian is actually one length of the radius. So here we have the radius going from the center to the side of the circle. What a radian does is it goes around that arc. That distance there is just one radius, and it's one radius around the circle. Now, theta, the central angle, is the length of the arc over the radius. We'll be talking more about that as we go through. Now, keep in mind, a circle's circumference is 2 pi r. So since r is that radius, a circle has a length of 2 pi radians. The circumference of a circle is 2 pi radians because the radius is that radian. So a circle is about 6.28 radians. So it's going to take about 6.28 of the radius to go all the way around the circle. So keep that in mind as we go through. We'll be talking about things as we see it, but this is kind of just our introduction. So you can see radians in a circle. You can see 1 radian get you there. 2 radians get you a little bit past 90 degrees. 3 radians almost get you halfway. 4 radians, 5 radians, 6 radians, and there's a little bit more than 6 radians to get around the circle. It's about 6.28 radians. So 2 pi radians. equals 360 degrees. So if we have a half circle, that's going to be half of 360, which is 180 degrees. So half a circle is going to be about pi radians. I know it's a lot at once. We'll get used to working with this notation. Now, because the radian measure of an angle of one full revolution is 2 pi, we can obtain the following. So half a revolution. Half times 2 pi is going to be pi radians. So a half circle is pi radians. A quarter of a circle, 1/4 times 2 pi, is going to be pi over 2 radians. And a sixth of a circle, 1/6 times 2 pi, is going to be pi over 3 radians. So some other common angles. So pi over 6 radians, that's going to be 30 degrees. Pi over 4 radians is going to be 45 degrees. Pi over 3, 60 degrees. Pi over 2, 90 degrees. Pi radians is 180 degrees, and 2 pi radians is 360 degrees. You want to get used to thinking about it in terms of pi radians and in degrees, and these are the most common that you're going to see. When we talk about on the coordinate system, so what we have here, we have this in radians and in pi radians. So theta equals 0, theta equals pi over 2, which is also, think about it as 90 degrees. Pi, that's 180 degrees. 3 pi over 2 is 270 degrees. And then we get back to that 0 degrees slash 360 degrees gets us back and starting a new circle. So when we're in quadrant 1, theta is going to be between 0 and pi over 2. It's going to be between 0 and 90 degrees. When we're in quadrant 2, theta is going to be between pi over 2 and pi, between 180 and 90 degrees. Quadrant 3, between pi and 3 pi over 2, so we're between 180 and 270. And then in quadrant 4, 3 pi over 2 and 2 pi were between 270 and 360. So when we think about these, if we're thinking about where 7 pi over 6 is located, now 7 pi over 6, that can be written as 6 pi over 6 plus pi over 6. Now 6 pi over 6, that's pi plus pi over 6. Now pi would get us to 180 degrees. Now we'd need another pi over 2 to get us into quadrant 4. So what we're going to be is, because of that, we're in quadrant number 3. If we're in 3 pi over 4. Now 3 pi over 4, pi over 2 is the same as 4 pi over 4. So what that's going to be, it's going to be between pi over 2 and pi. So that means we're going to be in quadrant number 2. If we have 13 pi over 6, we want to think about rewriting these. It's 12 pi over 6. 12 pi over 6, yep, plus 1 pi over 6. So what that is that's 2 pi plus pi over 6. Now 2 pi takes us all the way around the circle. So we can kind of ignore that 2 pi, and pi over 6, that's going to leave us in quadrant number 1. We went all the way around the circle, and then we ended up in quadrant 1. Another example, 11 pi over 6. So what that is that 6 pi over 6 plus 5 pi over 6, and that's going to add up to 11. Now 6 pi over 6, that's pi, plus 5 pi over 6. So pi would take us to 180, and then that 5 pi over 6, that's almost another full pi. So that would mean our angle would be down there somewhere, which would be in quadrant number 4. It's going to take some time to get used to this, but this is kind of our goal as we're working through it. So let's do some more examples of this. Some extra practice problems. Now, keep in mind, we have 0, pi over 2, pi, and 3 pi over 2. That's going to be our quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So for 11 pi over 8, now 11 pi over 8 can be written as 8 pi over 8 plus 3 pi over 8. So that's going to be pi plus 3 pi over 8. So if we think about this, pi would get us there. And now 3 over 8. Each quadrant, we're going 1/2. 3/8 is less than 1/2, so we didn't have quite enough to get us into quadrant number 4, so we're in quadrant 3. Nine pi over 8. That's 8 pi over 8 plus pi over 8. 8 pi over 8 is pi plus, and then we have that pi over 8 remaining. So think about this visually. That's going to get us to pi. And then 1/8 is less than 1/2, so that's once again in quadrant 3. Negative 11 pi over 9. Negative just means we're going clockwise. So that's going to be a negative 9 pi over 9 plus another negative 2 pi over 9. So like I said, this time we're going clockwise. So we're going to go down this way. That's our 9 pi over 9, our negative pi, plus a negative 2 pi over 9. Once again, the negative just means we're going clockwise. 2/9 is less than 1/2, so we're going to be there in quadrant 2. Number 4, that's negative 1 radian. Now, it's going to take a little over 3 to get halfway. So that means a quarter of the way, that's going to be approximately a little bit more than 1.5, or negative 1.5 in this case. So that means we're only going back 1 radian. So we're going to be in quadrant number 4. 6.02. Now, keep in mind, a full circle is a little bit over 6.28. So if we're going positive 6.02, we're going almost entirely around that circle. Not quite. So that means we're going to stop in quadrant 4. Negative 4.25. We're going clockwise. Now, halfway around would take us, that's a little bit over 3.14. So we're just going a little bit more. That's going to leave us around there, and that's in quadrant 2. The thing there is we had to go clockwise. sketching the angle in standard position. Here's where we're going to draw our terminal side and our initial side. So standard position, our vertex is on the origin. So negative 7 pi over 4. That's the same as negative 4 pi over 4 plus negative 3 pi over 4. So it's going to be negative pi plus negative 3 pi over 4. Now, we're going clockwise. So there's our negative pi. And 3/4 is greater than 1/2. So we're going to go from not in quadrant 2, but in quadrant 4. And there's our angle in standard position. Here's our initial side down here, and here's our terminal side. And I use the arrow to show that I'm going clockwise. 5 pi over 2. That's the same as 4 pi over 2 plus pi over 2. Now 4 pi over 2 is the same as 2 pi. That's one full circle and then 1/2. Or pi over 2. So 2 pi, we're going counterclockwise. And now that pi over 2 is going to take us right there to that axis. So there's our angle in standard position. Here's our initial side, and here is our terminal side. For 4. Now remember, we're going counterclockwise. About 3.14 will take us 180 degrees. So we're going to go a little bit past that to get to 4. And there we are in quadrant number 3. So here's our initial side here and our terminal side down there. And 7 pi. Now 7 pi is the same as 6 pi plus pi. And the reason I'm splitting that up is 6 pi is the same as 3 full circles. So we're going counterclockwise. 1 circle, 2 circle, 3 circle, and then we have an additional pi. There is our initial side and our terminal side. Now, radians are a little bit trickier to work with. We're way more used to working with degrees. So when you're working with degrees, remember here 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And then it goes back to 360 and keeps going. So now if we're going 120, much easier to represent. We're going there. There's our angle in standard position. Now negative 270. We're going clockwise. 180, 270. There's our angle in standard position. Negative 750. Now, negative 750 is the same as negative 720 plus negative 30 degrees. Now, that negative 720 is important because that's 2 circles. And then we have the 30 degrees left over. So we're going negative. We're going clockwise. 1 circle, 2 circles, and then an additional 30 degrees. It's going to leave us about there. So there's our initial side and our terminal side. And then 600 is the same as 360 plus 240. So the 360 is important because that's 1 circle, and then we're just worried about the additional 240 degrees. So for our 1 full circle, there we go. And now 240 is going to be between 180 and 270. So here's our initial side and our terminal side. I know it's going to be tricky to get used to working with this type of system, and that's what we're going to be working on in this first section, is getting used to working with these values. It's very important you do the homework for that additional practice to get used to this notation and this thinking process. Thank you, and have a nice day.